Okay, now I'm on number 4. Number 4 has a mass sitting on a surface. There's a piece of cord, passes over a pulley, and then there's another weight or mass, whatever you want to call it, right here. This one is M1, and this one is M2. So free body diagrams, I don't even mess with it over here. I come separate and I say, okay, so here's mass 2. It has a weight, which is mass 2 times gravity, and it has a tension. And then I look at the one sitting on the tabletop and I say, well, there is a weight. There's a force normal. And there's a tension pulling that way. I'm only interested in the forces that are accelerating the object. So these two are balanced and I don't need to concern myself with them. So now I'm going to write my equations from net F equals ma. But I need to assign some directions. I said that if I believe that it's going to accelerate that way, I'm going to make this be positive. This tension will be negative, and that tension has to be positive, so they'll cancel. So I'm going to do weight 2 first. That's the one hanging. And I say W2 minus T is equal to M2A. And then one that's setting on the table is W1. And it's T equals M1A. I'm going to add those up because I want the net force, and the net force is the sum of all the forces. So weight 2 is equal to the total mass being accelerated times A. Weight 2, we said, was 10 kilograms times 9.8 meters per second squared, so that's 98 newtons. The masses that are being accelerated is 10 kilograms and I think 6 kilograms. Okay, but look, I've got a fatal error. I should have had some friction here. My bad. So I got to go back and fix that. Alright, so the friction here, let's go back and repair. Not a big deal. Easy enough to fix. So I need to figure out what that friction is before I do anything. Well, friction is mu times force normal. So the mu is given to me as 0.19. And my force normal is going to be the weight, which is 6 kilograms times 9.8 meters per second squared. And when I did that, I got 6 times 9.8, 48. I think it's 58.8 newtons. So my friction is going to be 0.19 times 58.8 newtons. And when I calculated that in my problems, I think I got 11.17 newtons. So now I need to deal with that. So I have positive tension, negative friction equals M1A. So my tensions still cancel out, so I have weight 2 minus friction equals M1 plus M2 times A. Weight 2 is going to be 10 kilograms times 9.8 meters per second squared. Friction will be 11.17 newtons. Mass 1 plus mass 2 is 16 kilograms, and I'm looking for A. So when I solved for A, I said 98 newtons minus 11.17 newtons, and then I divided that by 16 kilograms, and I got 5.43. And it came out to be positive, so that means that the system is indeed moving in this direction, because that's how I defined positive. Then they want me to find the tension. So I'm going to go back to W2 minus T equals M2A. It doesn't matter which one you pick. 98 newtons was weight 2. Tension is what I'm looking for. Mass 2 was 10 kilograms. Acceleration was a positive 5.43 meters per second squared. So when I solved for my tension, I got tension to be 43.73 newtons. Alright, let's move on to number 5. Okay, number 5 said you have a ramp. And on this ramp you have a block. And you want this block to accelerate without friction. And then part B is with friction. So there's my weight. There's my W cosine theta. There's my W sine theta. This is my theta. This is my theta. So, part A, there's no friction. So the only thing sliding the block down the ramp is W sine theta. So W sine theta gives me my net force, and it's equal to MA. Well, W is mg. Sine theta is sine of 30. Masses cancel out. If that bothers you, a point of value for a mass, it doesn't matter, it'll work the same. Gravity is 9.8 meters per second squared. Sine of 30 degrees is a half. So the acceleration in this situation is 4.9 meters per second squared. Now I have some friction, so it's going to look very much like the same free body diagram. I didn't draw my force normal, and I'm going to need it for the friction, but I have friction in this direction. So let's go ahead and figure out our friction. Well, our friction is mu times force normal. Mu was given to us as 0.28. Our force normal is equal to W cosine theta. W is just mg. And our cosine of 30 is 0.866. So I multiplied all those numbers together, and when I did that, I got 2.38 meters per second squared times m, whatever m happens to be. So then net F equals ma. So I have W sine theta down the ramp minus friction up the ramp is equal to ma. W sine theta is mg sine 30. Friction we said was 2.38 times m, and all of that is equal to ma. But notice you have a mass, and a mass. So we already said that this was 4.9 meters per second squared minus 2.38 meters per second squared is our acceleration. So the acceleration is going to be saying one thing and writing another. Acceleration is going to be 2.52 meters per second squared, and it's positive, which means it's going to be down the ramp. So we know we're good to go. All right, number 6. Number 6 says, I have an elevator. So here's my elevator. Has a mass of 4,850.0 kilograms. And we know that the weight is mg. So we're going to take that 4,850 kilograms, and we're going to multiply it by gravity of 9.8. So when we make that math happen, we get 47,530 newtons. 47,530 newtons is the weight. The tension is pulling up, and they're asking us what is the tension in 3 different cases. When it's got 0 acceleration, when it's accelerating upward, which is positive, 1.6 I think is, yes, 1.6. And then when it's accelerating downward, which is a negative, and I got a negative 2.3. So if net F is equal to, let's go over here, if net F is equal to ma, then positive T, negative W, so T minus W is equal to M times 0. So that tells me that T simply has to equal W. So T is going to be 47,530. And that should make sense to you. If you just want to hold the elevator in place, you better be able to balance the weight with the tension upward. So now I'm going to go to this part, net F equals ma. So I still have T up, weight down. So T is going to be equal to ma plus W. Well, M is 4,850 kilograms. They want it to accelerate with a positive 1.6. And we already know the weight is 47,530 newtons. So when I did this math and added it to the math of the weight, I got 55,290 newtons. Then I went to this one, and I said, well, T minus W equals MA. T is what I'm looking for. The weight is still 47,530 newtons. The mass is still 4,850 kilograms. Be careful, though, because this acceleration is a negative 2.3. So I'm going to multiply that times that, which is negative, and then add this to it. And when I did that algebra, I got 36,375 newtons. Okay, we're done with this.